Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 7A assignment. All right, we'll start with number 1. Which graph indicates that y is directly proportional to x? So, two key things for directly proportional. It has to be a linear graph. So that takes this out and this out because those are not straight lines. And it has to go through the origin. Okay, if you'll notice here, there's the origin that just misses it. It's a little bit above. That's not it. That's a straight line, goes through the origin. So D is our graph that indicates that y is directly proportional to x. Okay. Number 2, for each table of values, plot the graph of y against x and then determine whether y is directly proportional to x. And if it is, find the proportionality constant. Okay, so let's graph this thing here. Just put up some regular old graphs. Let's see. We can just graph this all up here. So we can do 0, 2, 1, 4, 2 and 6, 3 and 8, 4 and 10. Okay, so it looks basically like so. Okay, determine whether y is directly proportional to x. If so, it would have to go through this point here. So this one is not. Okay, so since it's not, we don't have to worry about the proportionality constant. For D, we are at, let's see, we got to go all the way up to 35. So let's make these, just to make this nice, let's do each of these by 4s. So let's do 8, 12, 16. Sorry, yeah, we're going up by 8. Sorry, 24, 32, and 40. And then we can do the same thing this way. 8, 16, 24, 32, and 40. Okay? So, in fact, you know what would probably even make this easier? This x only goes up to 7. So let's just leave this as 1. And we'll leave this as by 4s, okay? That will work just fine. At 2, we are at 10, so that's roughly right about in here. At 4, we're at 20, which will be this one. At 5, we are at 30. So that's somewhere right up here-ish. And at 7, we're at 35. So about right there. So it looks like these kind of line up, but that one looks a little off. Okay, an easy way to tell that is if we do 10 divided by 2, our proportionality constant in this case would be 5. If you'll notice, that works for 20. Ugh, that's bad. 20 divided by 4 is also 5. 30 divided by 5 is 6, so that one's different. And you do 35 divided by 7, that's also 5. So these are all 5. This is the one that messes everything up, so that one is also not directly proportional to x. Though it looks like without that point, it might even, it's a little, my line's a little goofy here, but it looks like it might even go right through 0 here. Okay, but again, this 30 and 5 and 30 messes that up. Okay, 3, table below shows the cost of purchasing W kilograms of prawns. Draw the graph of C against W. Okay, so I'm just going to paste in a graph here. And let's see, we are going, you know what, let's do this. Okay, let's put in a bigger graph to kind of help us with these numbers here, make it a little bit nicer for us. So our x's here are just 1 through 4, so let's even do this. We'll start at 0. Let's do 1. Let's do every 2, 3, 4. 1, 2, 3, 4. Oops, not 4, but 3. And that's 4, and then that's 5. And then here we got to go all the way up to 60. So if there's 20 lines here, if we go by 3s on this, that'll get us all the way up to 60. So we'll do 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60, and that'll make this graph look a little bit nicer. So we have 0, 0 is one of the points. That's obviously key to show that it's directly proportional because it has to go through 0, 0. So that's a good start. And at 1, we're up here at 15. 2, we are at 30. 3 is at 45. And then 4 is at 60. Okay, now this should make a nice straight line that goes right through 0, 0, which it does. So that means it's directly proportional. Check. So we drew the graph of C against W. Explain why C and W are directly proportional. It is a linear, the graph is linear and it goes through the point 0, 0. Those are the two big things that we need to make sure that have to happen. And then C, find a formula connecting C and W. All right, so the cost is our Y. C equals some number times W, right? Okay, so let's do, we can even do this. Let's do, it's proportionality constant, usually K. So let's do this. C equals K times W. So we can even enter in 1 for W. So K times 1 has to equal 15. So divide, basically that 1 is gone. So that means our K is 15. So what we would do is write our formula would be C equals 15 W, and that's our formula, right? Because if you do 2 times, plug 2 into that, 15 times 2 is 30. 15 times 3 is 45. 15 times 4 is 60. So there's our formula, okay, that connects C and W. 5, suppose Y is directly proportional to X. State what happens to Y if X is doubled. So if we, basically what happens if you double X, that's simply just going to double Y, because like let's say on the last example that we had Y equaled 15X, right? On the last problem that we had to do on the assignment. So if you double this 15, now it turns into 30X equals Y. So it's just going to be twice as big. So what happens to Y if X is doubled? Y is doubled as well. Okay, because it's directly proportional, and that's kind of a key piece to that. Directly proportional. Okay, what happens to X if Y is multiplied by 6? Okay, so again, we can take the same idea. We started with Y equals 15X. What happens to X if Y is multiplied by 6? So if we do 6 times the Y, it's going to equal 15 times what? Times the X. So if you multiply this side by 6, guess what? We got to multiply this side by 6. So if Y, what happens to X if Y is multiplied by 6? X is multiplied by 6 as well. Okay, and that's because they're directly proportional. Later on, we're going to talk about inversely proportional, and that will change. That's kind of the lead into this of why we're doing this question, because later on it's gonna we're going to talk about inverse stuff, and it'll make more sense. Okay, suppose Y varies directly with X, and that Y is 24 when X equals 7. Find Y when X equals 21. So I'm going to just simply set up an X and a Y. Let's see, our X is 7 when our Y is 24. Find what Y is when X is 21. Okay, so since it's directly proportional and its Y is directly proportional to X, we can just simply set up a little cross multiply, right? 7 over 24 is going to equal 21 over Y. So this times this is going to equal this times this. So 7Y is going to equal whatever 24 times 21 is. Okay, so 24 times 21 gives us 504. Divide both sides by 7, and that will tell us what Y is. So divide by 7, and we get 72 for this Y right here. Okay, and another way to look at this also is, oh look, 7 times 3 gives us 21. Guess what? 24 times 3 is going to give us 72. Okay? So, now same idea here. We still have x is 7 when y is 24. Find x when y is 30. Okay? So, 7 over 24 equals x over 30. Cross products. 7 times 30 is 210 equals 24x. Divide both sides by 24. And we will get that x equals something. 210 divided by 24 gives us 8.75 for our x. Okay, last one to take a look at, number 10. The amount of energy used by a heater is directly proportional to the time that it's on. When it's on for 2 hours, the heater uses 3.6 kilowatts of energy. Okay, so directly proportional to the time that it is on. So the energy, I'm going to put down here as the y, and then the time is going to be my x. And again, this will, since it's directly proportional, it'll work either way. It doesn't matter which one you put as x, the x and the y spots. Okay, so when it's on for 2 hours, it uses 3.6 kilowatts of energy. Find the proportionality constant and explain what it means. So we would just take its rise, that's the slope, right? So it's the rise over the run. Rise is the y, and run is the x. So we do 3.6 over 2. And let's see, 3.6 divided by 2, that's going to just be 1.8, isn't it? Yeah. Equals 1.8. Okay, so we found the proportionality constant and explain what it means. Okay, so 1.8 is the number of kilowatts of energy it uses every hour. So 1.8 kilowatts hours of energy used per hour. Okay. The energy used by the heater if it's on for 1.5 hours. So now we could simply just do a 1.5 here, right? And then we could set up as 2 over 3.6. This is part B. It's going to equal 1.5 over our E, we'll call it, for energy, right? So this times this is going to equal this times this. So 2E is going to equal 3.6 times 1.5, which gives us 5.4. Divide both of those by 2, and we get that E is going to equal, let's just do this the easy way, because we already have it in there. Divide by 2, and we get 2.7. So that means it uses 2.7 kilowatt hours if it's on for 1.5 hours. Right there. Okay. What would the time it would take for the heater to use 6 kilowatts of energy? So again, we still have the same setup here, because 2 and 3.6. And then they're saying the time it would take for the heater to use 6 kilowatts of energy. So 6, and then that's going to be T, right? So 2 over 3.6 equals T over 6. Cross multiply and divide. We get 12 equals 3.6 T. Divide both sides by 3.6, and then the time will equal 12 divided by 3.6 gives us 3.33 hours, so 3 1/3 hours, so 3 hours and 20 minutes, right? 3 hours 20 minutes, because 20 minutes is 1/3 of an hour. Okay, all right, that's all we have for this here. If you have any further questions on any of these or anything else from the assignment, please feel free to ask. Thanks.